We should have started recording. Thank you very much. Thank you very much to all of you for coming to this chemistry and AI talk. My name is Aslam Guma. We're part of the BEAR team, which is the Birmingham Environment for Academic Research. You may or may not know of us, but we are part of IT services, and we are specifically focused on research, on how we can provide services for research for our postgrad community, for our researchers on the university at the University of Birmingham. I'd like to introduce my colleagues, Jenny and Gavin. They're both part of the BEAR team. They're specifically part of the research software engineering group, and they'll introduce themselves to you shortly. So this is a short talk around Baskerville and GPUs and AI and everything around the fact that the new service we've just recently launched and how we can kind of utilize that to kind of push the research up from your side of it, what availabilities and what utilities we have, what hardware and software we have that we're able to have to be able to help you with your research. So I'd just like to introduce you. So just a quick aside on this. If you've got any questions, please unmute yourselves and ask the question, or if you want, you can put them in the chat and I'll read them out for you. We're kind of fairly free form. You can ask questions at any time as well. So just hand over to Gavin.
Thank you very much, Aslam. Just trying to unmute myself there. So my speech is going to be on Baskerville. I will also remember to share my screen. So can everyone see my slides up there? Perfect. So I'm going to be talking about Baskerville, which is our, I guess, a year-old now Tier 2 HPC system. And I'm going to just talk about a little bit about how it operates, how you get on it, and all of the features we have with Baskerville. So first of all, why Baskerville? So Baskerville was named after John Baskerville, a Birmingham industrialist, and we were driven by the name. And also a small bit of trivia, that's how we got the font for the B is also the Baskerville font. It is an EPSRC funded Tier 2 system. So if you know a thing about HPCs, Tier 3 is still normally local and institution, so that one will be BEAR in Birmingham or Blue Bear in Birmingham. And Baskerville is a Tier 2 one, so it has a much larger outreach. And we've got a few, I guess, consortium partners, Diamond, LightSource, the Rosalind Franklin Institute, Alan Turing, as well as a few technological partners, NVIDIA, Lenovo, OCF. And so that's just a little bit of the history. That's the group behind Baskerville. And well, I guess it is mainly focused on GPUs. And one question might be, why GPUs and their influence? The quote above is by Tai-Sung Lee, who is a professor at Rutgers University. And what it says is that today's researchers can take advantage of GPUs to approach computational models for drug discovery and design that are accurate, affordable, and achievable. With adequate computational resources, it is now possible to optimize a lead in days or weeks instead of months. GPUs, for a lot of things, are faster. And there's a greater adoption of GPUs on a lot of more traditional CPU-focused applications with additional resources to enable upskilling of no GPU-accelerated code. These are both provided by a lot of, by say, NVIDIA and some of the applications they have, and also various sites that you can find lots of information, but also Baskerville itself helps users to upskill in a large amount of ways. One quick study that I guess that NVIDIA did was how many CPU nodes can be replaced by a single GPU accelerated server. And the GPU accelerated server in this case was the A100, which is what Baskerville has. And they did a few case studies. I chose a couple: molecular dynamics software, so Amber, Gromax, LAMPS, NAMD, Relion, and a quantum mechanics one, Quantum Espresso. And they tested on up to 8 CPU servers and did linear scaling above that. And you can see for, say, Gromax, it is one A100 GPU, one A100-based GPU node is equivalent to 22 CPU servers. For Quantum Espresso, it's equivalent to 15. That's just the speed up you get whilst using GPUs in comparison to simple CPU-based applications. And with that, what does Baskerville contain? It contains liquid cooled compute trays composed of 8360Y CPUs, which are Ice Lake based, and they contain each node contains 4 NVIDIA A100 40GB GPUs connected via NVLink. This is, you can see all the stats there with the +5 terabytes, +5,000 terabytes of storage, or 5 petabytes of storage. This is what we have installed now, but we're in the process of adding some additional A100 80GB trays as well, just to expand our facilities for the users. Access in Baskerville can be done for anyone who's interested via the website shown in this link here. And we do, for Birmingham-based individuals, 6 months substantial projects. So every 6 months, you can apply to either start a new project or renew your project. Or from the 1st of July and in January, those are the time periods. And if you do, you can also apply in between those times. But if you do so, only be up until those 6-month breakpoints. And if there are any questions about your application, you can message me and I can go through, review the question process and what is expected. Normally, we like a rough idea on the number of GPUs you may plan to use for your project, but there isn't necessarily a GPU limit for you, but we just want to make sure that everyone is using it to the most, or the maximum amount of their abilities. With Baskerville, we tried to, again, in encouraging people to use Baskerville and GPUs, we have a lot of resources available for everyone, from our public-facing website. We have an admin site where you can see your project and use information of all the users on your projects and the amount of memory you are using in your work. Baskerville applications. So if you want to use Baskerville, and if you're familiar with Bluebear, it is very much the similar thing of loading modules. We have a fair amount of applications already installed in Baskerville, with more upon your request. And we also have a portal application for GUI apps and Jupyter notebooks for you to use. Looking at we have the docs website, which contains a lot of information about Baskerville. And if you want to have a look at it, I do recommend doing so. And you can view through different aspects, from how we store data, request and access, more information about the portal. And if you become a user of Baskerville, have any questions, this should be the first point of call for you to look at. We also, again, in some of our training and upskilling, get people used to how Baskerville operates. Even if people do have prior HPC experience, Baskerville might be slightly different to what they are expecting. So we also have a little training course with Baskerville Basics. And this is just an introduction to use Baskerville and how to create a submission script that will operate on Baskerville, and utilizing GPUs and the effect of what happens if you do more GPU, try to assign more GPUs than you can, what's the error message. And this is just to go through different steps, so you know from this training what better to analyze what could possibly go wrong. Combined with that, we are doing lots of other additional training resources for users, including videos, and we've got a few NVIDIA training sessions coming up in the future that might help you, particularly with AI and maximizing GPU usage. That will happen in the future. Here's the Baskerville application website. At the time I took a screenshot of it, we have 282 applications. You can browse through them and see what we have available that might be of use to you in using Baskerville. And I think that's it for my presentation. If there's any questions, please let me know.
Oh, Dick.
Thanks a lot, Kevin. I have a question, because I mean, so I just, while you were presenting, I had a look into the docs and I found Slurm. Never heard about Slurm before, so I guess whenever someone is going to start with Baskerville, people will have to learn a range of things like this other language here. The question is, is this something that could be done? Basically, learning this, is this something that could be done on a regular Bear account, or do we already have to start with this tier 2 high performance computing account to get people trained on those things? And then with the 6-month period, So if a student works on something for a couple of months and then he leaves the lab, and then it takes maybe another year to get another student back on this project, I will need some space somewhere to store what had been developed before, and then to revive it later on, I guess. So how is this going to work?
That was a very good question. So the first one with Slurm, Bluebear also uses Slurm. And so if you have a Bear account and you can use the same scheduler, you have the same scheduler on Bluebear. And if you have any submission scripts or the like for Bluebear, they will be very similar for Baskerville. And the Baskerville basics goes through some slight differences that that might arise. But you can do everything on Bluebear that you can do on Baskerville. With Baskerville, we also have some A100 GPUs with Bluebear, so we also have some A100 GPUs that you can possibly request. Not as many, and there's a much larger queue for them. That's why we like to get people onto Baskerville who think they'll be using a lot of those resources. With the Baskerville account every 6 months, what that could mean is that if you have, say, a Bear account, Bear storage, you can move things from Baskerville onto Bear. That way, if needed, if it is just for storing things, you can, every 6 months you get a message saying your project is running out. So there's a period where you won't be able to run anything after those 6 months. But I think there's around a month or so past that where you can still move data back and forth from projects. We are just starting. So in the first year, we haven't actually deleted, we've just started deleting projects. So they do stay for quite a while. But I would say that if someone leaves and is away for a year, I would move to Bluebear, then move back again, and just keep what you said when you submitted the first application. Say we did it before. Having prior Baskerville experience also does help in your applications for renewing time period.
I think also with Slurm, our colleagues in the RSC team can also help out with just giving some odds, and there's some basic information of what you need in the submission script. So absolutely, there shouldn't be any issue with Slurm.
Yeah. Just to add to that, the Baskerville basics, you will build a Slurm script from that training course. So at the end of it, you will have an example script to run off of.
Enjoy.
Hello, hi. Thank you, Gavin, for that very informative talk. I have a question. So what if I want to build everything myself? I want to build my virtual environments. I want to compile everything myself. Is that possible?
Yeah, so as a tier 2 system, we expect a lot of users to have, we expect some users to have a lot of HPC experience. And if they want to be left alone to have their own little environment to do their thing, we just say, go on. The only difficulty is that if you have a problem, it might be harder for us to help you, because we like to respect every user's personal project space and their own environments that they have there. So it might be harder for us to debug for you.
Yeah.
But if you are comfortable and confident in your space, we're more than happy to allow you to do so.
Okay, that's good. That flexibility can be useful sometimes. So what about so how do you do that then? So say I run some training of neural networks, which takes a lot of space. And do I do that on some sort of scratch space, or do I have a huge home directory where I can run everything from there?
Not your home directory, but you have your project directory, and that would be the assigned space. We set a default of 1 terabyte, but you can request more in your application.
But there's no let's say a communal scratch space that is enormous, and you can dump all the intermediate data there, and no. Okay. Yeah. Thank you. That was my question.
Will that cause a problem, Linjing?
Not necessarily. obviously this is a GPU machine, so yeah, no. I guess that could be a problem with if that's the way we run calculations on Bluebear, that could be a problem for some of my calculations because they generate a lot of large intermediate, let's say, scratch files, and that can easily go beyond the limits I have for the project. But I guess having access to some scratch space could be helpful. If not, then I have to take that into consideration when I request for the project, I guess. That's the other way around, I think.
We do have some information on scratch space on our docs site.
Okay, I need to check that out.
Yeah, it can be a bit confusing when it mentions the temporary and scratch storage, and we do talk about our scratch global.
Yeah, if I can answer that as well, Gavin, like I think the stuff that's on Scratch as well might not be accessible, like in terms of networked, like the network connections, it might not be accessible as well. So say if you launch a job, that job might not be able to see files on the Scratch space because it's not part of the same network. So you do have to be careful about where you put your data. And I think, correct me if I'm wrong, Gavin, as well, that each node you could possibly put data in the temp directory on a node, but it will be cleaned once you finish your job. So there are different options depending on what you need.
Yeah.
Can I ask, would you expect us to have piloted work on Bluebear, perhaps using the GPUs there before coming to Baskerville?
No, it's not necessary. Especially we're trying to reach out to people, especially those who don't traditionally have GPU experience, to get them on board with HPCs and Baskerville.
Right. Okay.
Gavin, assuming there's support from the RSC team to help with that as well.
Yeah.
Yeah.
And I see Chris put a question in the chat about the wait times for GPUs on Baskerville compared to Bluebear. And we like to show off some graphs on the Baskerville team about their wait times, where it's dependent on the amount of resources you want, of course, but normally people don't wait any more than 24 hours for submitting something, for their job submission to get in the allocated resources. But that's typically on average. If you were to request a good amount of nodes, it might take a long time for it to find the space for it. But normally if you're doing 1, 2, even a node, it should take less than 24 hours.
Excellent. If there's no more further questions, I think we'll move over to Jenny now, while she's having a drink.
Share my screen. Okay. Can everyone see that?
Yeah.
Okay. Right. Got many toolbars and stuff. Okay. So my talk's less about the HP system about itself and more about artificial intelligence and the software packages that you can use. So yeah, my name's Jenny and I'm a research software engineer within the Advanced Research Computing team in IT services. So as previously mentioned before, if you want more support about how to do certain aspects of AI computing or help with putting your code onto Baskerville or Bluebear, then we're here to support you in your research and doing that. So in this talk, if I just, oh no, lost my, here we go. I can click on to the next slide. I just thought I'd want to sort of start off with a couple of use cases here at the University of Birmingham when it comes to chemistry and artificial intelligence. So I did some digging around and so the Chen group, so yeah, Chen is in this call right now. One of their applications, correct me if I'm wrong, is to use artificial intelligence to implement some automated laboratory protocols in a process called called closed loop drug discovery. So I think the intention is to use artificial intelligence to make some really highly accurate predictions on the reactivity of molecules or compounds. And using those predictions from artificial intelligence, they can be done in real time to inform iterations of an experiment for target processes. So yeah, one of the aims is to use artificial intelligence to have a very closed, autonomous approach to iterating generation of target drugs in this design, making, testing, analyzing process. So that's one use case, for example, that I hear at the University of Birmingham. And then in the Albrecht group, we can use artificial intelligence to interpret data in a way that humans can't, programming in real time. So this application is with regard to single molecule science. So there's a lot of data that's generated from various sensors, and a lot of data needs to be processed in sequencing, and also analysis needs to be made in order to characterize certain single molecules. And this can altogether generate huge data sets. And so machine learning can very easily, nowadays, you just run an algorithm to try and detect common features within the data set without us as humans making a priori assumptions about this data set. So there's a couple of algorithms that you might have heard of that I've just listed on this slide here when it comes to these algorithms. So one is a supervised method called support vector machines. And there's another unsupervised method that you could use called convolutional neural networks. There are plenty of algorithms out there, but here are just a couple that I'm just pointing out in this use case here. So that's the motivation, but maybe I should probably drill down as to what artificial intelligence is. I see a raised hand, I think. Yeah, okay.
I have just a brief question, because I had some discussions about different algorithms like convolutional neural networks.
Yeah.
There seem to be a lot of applications in the field of image analysis and image interpretation.
Yeah.
And I'm wondering how limited they are in terms of their applications. So if we would instead kind of turn molecules and molecular structures that could be encoded in specific codes, that it becomes more a language problem. Would those convolutional neural networks still be useful for these kind of problems, or do we have to talk to some expert who knows about other artificial neural networks that are better suited?
Yeah, I think like when it comes to this particular application, I'm probably not the best person to place to answer that question, but like from what you've said, that it becomes more of a language problem. Convolutional neural networks are used in natural language processing type problems as well. So I don't know exactly, but there is that application there. So if it does map like that, then there is potential for convolutional neural networks to work in this case. But I would advise maybe looking a bit more into maybe asking someone a bit more familiar with the chemistry side of things in that, because chemistry is not my domain. But yeah, that's as much as I can say about that. I don't know if that answers your question, but I think it could be promising. Yeah. Yeah, so if I continue, I just wanted to give a brief overview into artificial intelligence, because I know people watching this presentation might not have an idea of what it might mean, and there's a lot of interpretations of what it might mean. In the case that I'm sort of using it for, it's just automated compilation and analysis of data to generate human-like suggestions to solve problems. So in my previous slide, I referred to supervised versus unsupervised learning methods. So when I say supervised, I mean we're working with labeled data sets. So a labeled data set means it's something that contains a ground truth that we know already about our data set. So for example, this photo contains a cow. This is something that we can label this photo with, saying a cow, and that could be inputted into a training model, and then the model will be able to make inferences based on that. And so supervised learning problems can fall into two main subsets. So we've got classification type models. So these are problems such as separating apples from oranges, for example. So you want to separate and classify your data set into these categories. So this is something that a supported vector machine might be able to do, for example. And then they also fall into regression type problems as well. So if I have a lot of input data, then I want to train a model on this to predict some outputs from that data. So this is a regression problem. An example of this could be, I'm watching football, and based on the stats of each game, I want to predict the outcome of the next game that Chelsea play or something like that. So that could be a regression type problem. And then an unsupervised learning model is where the user doesn't feed into this ground truth that I mentioned earlier with the labeled data. So we're mainly dealing with unlabeled data, and the machine learning or deep learning algorithm, would infer themselves naturally the structure of the data set with no, our input, no a priori labeled input data. So for example, in this little image here, a deep learning algorithm might identify some large scale features that separate the Donald Duck, is that, and a Mickey Mouse and a Bugs Bunny from other characters, and then classify them as ducks or whatever animal category you have there. So that's an unsupervised learning example. And so this particular one here about classifying things into like ducks, a mouse, and a Bugs Bunny would be a clustering problem. So again, it's kind of like classification, but the unlabeled dataset version. And then also unsupervised learning can also deal with dimensionality reduction as well. So it can figure out for itself that the model can eliminate some redundant features in your data set. So that's what we mean by dimensionality reduction. And this is great because it means you have less intensive computations when you're processing data. And this is what essentially convolutional neural networks will do. So I'm just going to talk about some software or applications on Bluebear and Baskerville that allow you to do this within a programming language. So the first programming language I'm going to talk about is Python, because it's one of the most popular programming languages in the artificial intelligence community. It's open source, and there's many high quality artificial intelligence packages available using Python. So you might have heard of these before in the AI circles. So the first one is TensorFlow. It's a general AI package, but there's a bit more of a focus on training deep neural networks. Keras is used to interface with TensorFlow. And it provides a more user-friendly high-level APIs for you to talk to TensorFlow with. Oh, sorry, I just skipped ahead by accident. Okay, and then I was about to talk about PyTorch. So this is a different Python package, which also focuses more on deep learning algorithms. So deep learning meaning more like unsupervised training models, and examples of applications of deep learning could be computer vision, and we mentioned earlier about natural language processing as well. So PyTorch is equipped to do those things. Scikit-learn is another, all of these packages are open source, by the way. Scikit-learn deals more with machine learning algorithms, so more supervised learning, and integrates well with many other Python packages as well, such as NumPy, Pandas, and Matplotlib for plotting. So if you're familiar with these packages, Scikit-learn integrates very easily with those other things. And then in terms of acceleration, so Rapids is an ecosystem which allows you to do most of these things, but on a GPU. So natively, these previous packages would run on a CPU, but Rapids allows you to do this all on a GPU. So if you're interested in running these types of packages on Baskerville, Rapids will be available to help you execute your code on GPUs as well. And another package that helps you speed up your computing is Dask, which rather than helping you, so you've got your code on a GPU, you might want to use multiple GPUs, and you might want to use multiple nodes to further distribute your code and scale out your computations. So Dask is a very handy library that allows you to do that quite easily. You can also do that for CPU-based jobs as well. So Dask allows you to distribute both types of jobs. And then Horovod is another package that helps you scale out or scale up your computations. And it's more tailored towards TensorFlow, Keras, and PyTorch in many ways. So that's talking about the Python ecosystem. If you program or are more comfortable in other languages, there's also packages for Java. So there's a Knime package, K-N-I-M-E, not sure how you pronounce that, but it's a visual programming language that's based on Java, which has all of your standard ML routines on there, written and optimized for you. There's also a package called Weka from the University of Waikato in New Zealand. Sorry if my pronunciation isn't good there. And then if you're an R user, there's also libraries in R that are available in the community. So things like Carre, which has a lot of classification and regression training methods in it. There's things like Data Explorer for feature engineering. We have KernLab and MICE, which stands for multivariate imputation by chained equations. But I'm not an R user myself. But MATLAB as well, if you're a MATLAB programmer, there's lots of standard toolboxes within MATLAB that can aid you with your artificial intelligence needs. So we've got toolboxes like the statistics and machine learning toolbox, we've got the deep learning toolbox, image processing toolbox, and many more, which are available on Bluebear and Baskerville for you to use. So that's the end of my talk. So thank you for listening. And yeah, let me know if you have any questions or comments.
Thank you very much indeed, Jenny. Are there any other questions?
Do you have a sense of how well the MATLAB packages work in comparison to, say, the Python ones? If you were starting from scratch and developing a whole new code, would you start in Python or would you start in MATLAB?
Okay, I don't think there's a single answer to this question because it really does depend on the user's previous experience and what they can get out of programming in those languages. I used to be a MATLAB programmer way back, and I switched to Python because for me personally, I enjoy having more open source packages available, and there's a lot of documentation out there and you're not sort of locked into that MATLAB ecosystem. And as I said earlier, Python is super popular with AI communities. So you can find so much resource out like online out there if you want to do, if you want to do machine learning, deep learning using these packages. So yeah, I've moved to Python now, and this is speaking from personal experience, I would go with that. But yeah, it really depends on the user's background and how comfortable they are with that. So yeah, I'm a lot more knowledgeable about answering questions around Python and ML. But yeah, I hope that helps.
Yeah, thank you.
Gavin.
I'll just add to that, that MATLAB isn't available on Baskerville at the moment, just with how MATLAB licensing works. So if that was going to be in your consideration, that would be something to add in there.
Okay. So I would like to add on that as well, but with a question maybe. So is there any notebook interface available in Baskerville for the Python programming? Because I did a lot Python with Jupyter Notebook and found that quite comfortable to learn things and try out things. I find it even more comfortable than MATLAB, I have to say. Is there something like that available in the Baskerville system as well?
Yeah, there is something called a Baskerville portal. So Gavin referred to some GUI applications that are available on Baskerville, and so yeah, you can launch a Jupyter Notebook from there straight off. You don't even have to like SSH into a terminal and things like that. You can just log into the website and then launch a job from the website. It's just a very simple graphical user interface, and yes, and launch a Jupyter Notebook from there. It's really nice on Baskerville, I have to say.
Then on that, I definitely would recommend using the Python with the notebooks instead of going for MATLAB, which is kind of also very specific in terms of its own language.
It is, yeah.
With the licenses and everything. No.
Yeah. I think, having to renew your license or if you go somewhere else, it kind of hangs over you. Python definitely feels a bit more flexible, shall we say? Yeah.
Cool. Any more questions?
I have a couple questions. So may I ask a little bit about the role of software engineers at Bayer? So what sort of the level of involvement you would be happy to get with, let's say, actual research projects going on in the individual departments?
So that's many different levels. So what for anyone who wants to utilize our software engineers, you can liaise with them on an ad hoc basis, or if you have a project in mind, then they're more interested in giving you like I think it's a 10-day limit per project. So it's a more of a to and fro of a contract of making sure they understand what you need, you understand what you need, and more of a knowledge transfer of how we can get, so specifically use cases where you guys don't have time to write some code that you just write. You need to do this, or more likely they would more interested in say if you got a student or yourself would like to learn a bit more of a specific part of a language, then they would have these like half day, and then you go to and fro with them, and over a period of 10 full days, you'd be able to kind of learn that, and they'd be helping you to kind of achieve that level of knowledge. But then there's also the final one where if you need an RFC resource in your team, so you'd build that into your project or your grant application itself. So you'd have like a half an FT or a 1 FT for so many days or so many months, and you build that into your project. And what would happen is we would allocate a pool RFC person into your project. So there's different levels.
Yeah, so I'm a pool RSC, for example. So half of my time I've been embedded in a research team in the medical school. So half my time I help them with their programming problems, and that's been for 6 months now. And then now I'm about to start a new one, and that's how that works.
Okay, thank you. That is very helpful. Yeah.
And there's some information we can pass on to you later on about how you can build that into your grant submission forms and stuff.
Cool. I have another question, Aslam, because in your response you touched, I think, a very important point, and that is students and students having to learn Python interfaces and what have you, right?
Yeah.
So Because I'm really wondering how fit the students in chemistry in particular would be for these kind of tasks, that you can put them into a project that maybe involves a little bit of software development, or at least being able to speak to a software developer, because I think there is also kind of a natural language barrier, right? And are there thoughts around setting up some seminars to train interested students from the different schools and colleges? Or
Absolutely. So we do run something called software carpentry training. So we have Python, R, NVIDIA courses, which we set up and run. We've Jenny and James, who was also on the call, have just certified in NVIDIA courses. So we'll be running those as well. So we have them available. So they're currently, so far they've been online, but we've just started having them on face-to-face training, so R as well. So yes, absolutely. We get them to a level whereby we can, if they can get to start using the services, and then they'll pick up the language as and when. And if you wanted to kind of, as I said, for a 10-day kind of per project initiation with to help coach these students as well in that project, I think that would be really useful, because I think one of the things we want to try and get over is how do we kind of knowledge transfer information from our RSCs to our upcoming PhD students who can then utilize that with their research.
Yeah, I just want to shout out that we're actually running these NVIDIA courses quite soon. So we have a Fundamentals of Deep Learning workshop happening on the 29th of June that James Alsop is running and I'll be supporting. And then we also have a data engineering workshop, which is also NVIDIA certified, happening on the 6th of July. So I think Aslam's just put up a link to training courses, so you can direct your students to sign up for courses on that link as well.
Yes, I just wanted to say that, yeah, these training courses are hugely valuable to PhD students. I have a question about the format of delivery. So with something like you take a cohort of students and you take them through a few different courses instead of, in addition to what you do this separate training courses where people just sign up to them. So is that something you would consider doing? So you take a cohort of students through a series of training courses, so they have a more formal training.
Absolutely, that's a good idea. I mean, we'll go back to our team and that's if that's possible. I think for us, for our training courses, we kind of, because they're online, we have about 50 places, but unfortunately we may end up about 5 or 6 people. It's about people's commitment. We've always had issues with people, crying off at the last moment. I mean, generally they may have issues on the day, or sometimes they've said, they've got labs to do and stuff like that, or the supervisors call them to do something, which is fine. But so when they don't reply with saying, I can't come, so we kind of put all the effort in to do it. But absolutely, if you are able to do this in a way that we have consistency and we have, like, say, 10 people in that group and they're consistent.
Yeah, I think it's something like class of 2022. They will be proud of it.
Yeah, absolutely. I mean, we could actually, chemistry has always been, for our team, has always started with chemistry from a very, very long time ago. So the relationship with us in chemistry has always been there. So maybe we can start this off so we can find out whether or not if this is viable for us. Because we have now the
I'd be very happy to involve in any such discussions from the chemistry part and help facilitate anything from our side, for sure.
I'll talk to my colleagues and then we'll get back to you if that's okay.
Okay, great. Thank you.
Very welcome. Right. Okay. I don't think there's any more questions. So